Stanford University.
Okay, well, welcome to CS 193P, Lecture 12, Fall 2013 and 14. And today we have one topic only, which is core data. And as someone was asking earlier, assignment 5 is due on Wednesday, and then your last assignment, assignment 6, will go out then and be due a week later. On Wednesday, I'm going to be going over the final project requirements, and we're going to continue with core data a little bit, talk about core data with UI table view, and then I'm going to do a big demo. So today's lecture is going to be all slides. I don't usually like to do that just because it's an awful lot of slides all at once, but it makes sense in this case, and I'll be doing the demo for today's stuff on Wednesday. And the next week we'll start talking about advanced segueing, and maybe we'll do some MapKit, multitasking. Not quite sure what I'm going to cover next week because you won't have a homework assignment on that. This core data stuff that we're covering today and Wednesday, that's going to be the topic of your last homework assignment that goes out on Wednesday. So core data, what is core data? Core data is an object-oriented database. Why do we need it? Because in any kind of significant application where we have a lot of data to crunch on, we can't be storing it in NS user defaults or not storing it at all or always fetching it down from Flickr, right? So your current assignment or the Shutterbug demo that we did last week, we're just always fetching our entire model basically every time we want it from Flickr. But what if we had a very large database of photos that have thousands or tens of thousands of little pieces of information about photos? We couldn't be fetching that down every time. We couldn't store it in its user default. So we need a real database. Plus, a real database allows us to make really smart queries about what our data is. Right now, we can't really query it at all, or almost not at all. We're just kind of displaying it all in tables. So to take the next level of sophistication in our app, we need to do that. So core data is a very, very powerful framework in iOS 7, one of the most powerful in terms of what it can do. I can only just barely scratch the surface in a lecture and a little bit this week. I'm just going to try and get you the basics, and you're going to have to, if you want to do a serious database app in your future, maybe for your final project or beyond, you'll need to do a little bit of extra reading up because core data is massive, okay? But fundamentally, it's a way of creating objects, Objective-C objects that you are going to deal with that are mapped or linked to SQL or XML databases, okay? So it's kind of a bridge between object-oriented land and database land. And database land is dominated by things like SQL, okay? How many people here know what SQL is? Not know how to program in SQL, but know what it is? Yeah, so everyone pretty much. So that's mostly what core data is hooked up is SQL backend. So how does core data work? First, you create a visual map using a tool in Xcode, okay, so dragging and dropping and all that stuff to create a mapping between an object-oriented view of your data and the SQL or tables and rows version of your data. And core data allows really that to be pretty seamless once you've created this mapping, and we'll talk all about that and how it does that. But let's start by looking how we create this visual map in Xcode. Okay, so first, we create the map by doing new file. Anytime we want to add something new to our project, we're going to do new file. But in new file, instead of doing like Cocoa Touch Objective-C class, we're going to go down to where it says core data. See that? And pick data model. Don't accidentally pick mapping model. It's data model that you want here. Okay, the data model is the mapping between the object-oriented world and the database world. So you click that. It's going to ask you what you want to call it and where you want to put it. Some people like to call their model file model if they only have one. Some people like to name it the name of the application. So like if last week, if we were doing core data, we might have called it Shutterbug, the name or thing. Sometimes you might have multiple mappings, and it is totally possible. And in a big application, you might well have multiple databases, multiple mappings, and so you would have multiple files. So you want to pick names for your mappings that kind of correspond to what their purpose is inside your application. So, but here we're going to take the default, which is just model. And you can see that it creates this new file. If you look over in the navigator over there, model.xc data model D, okay? And this is our mapping, our visual mapping file. And you can see here that it has some components and we're going to talk about most of them. The components are entities, attributes, relationships, and fetched properties. Okay? So entities are kind of like objects. They're going to map to our objects. In the database world, they're tables. Okay? Attributes are kind of like the columns in a table in a database. In our object-oriented world, they're going to be properties on objects. Okay? Relationships are also properties on objects, but they are pointers to other objects in the database, okay, or pointers to a bunch of other objects. Okay, so these would be kind of like joins between tables in a database sense. Fetch properties are kind of a calculated way to have a pointer to some other properties. I just have to cut something for time, so we're not going to talk about fetch properties. They're really not that complicated. Once you understand how fetching works, much later in this lecture, then you'll kind of get the idea, oh, I could see how maybe fetch properties would work, and then you can read the documentation and figure it out. So that's what the data model consists of: entities, attributes, relationships. That's what we're going to talk about. For our example today, let's say we had a Shutterbug-like application that had photos and photographers. Okay? So your homework is going to be more places and photos. Our demo here, and the demo I do on Wednesday, and the slides are going to be photos and photographers. So those are the two things that are going to be in our database, photos and photographers. So let's create an entity for the photos. So we click Add Entity down there at the bottom. We get this entity. I'm going to change the name from entity to photo. So this is going to be my photo object in the database. And then I can add attributes to my photo object by clicking on that little plus underneath where it says attributes there. And when I add one, it adds one called attribute. I'm going to change the name of that to title. So photos have a title, so I'm going to put a title in there. And you notice as I do this, I get an error, a little red error warning up there. Why is that? That's because the type of my title is undefined. You see where it says type undefined next to title there? So that's not allowed. You have to specify the type of all the properties in your database. And so you just click on that undefined. I'm going to set this one to be a string. The title obviously is a string. Now, what can some of these things be besides strings? Well, they can be numbers, either integers or floating point numbers. Those are all represented in the database as, in your object world rather, as NS numbers. Okay? All your properties, in fact, all the attributes in your objects in the database, all their properties are going to be objects of some sort. So NS string objects if they're strings, NS numbers if they're integers, floats, or doubles, or booleans, NS dates if they're dates, NS datas if they're binary data, that's the second to the bottom. And then transformable is kind of an interesting one. Those will be NS data objects, but you'll provide a little transformable object that will convert them to some other type, like even a C struct or something like that. And we're not going to talk about transformables, but it is possible to store really any data type in the database as long as you provide a transformation object that will convert them back and forth between an NS data. Okay, so here title is a simple one. It's a string. I'm going to add a whole bunch of other attributes here that you can kind of look. It's no more error there right now that I said it as strings, no more error. If I add a whole bunch more, you can see I've added an upload date that I got from Flickr, so that's a date. Even thumbnail data. So let's say I downloaded the thumbnail image data, the image data for a little thumbnail of my photo from Flickr. I can actually put that data in the database as an NS data. Some people ask, how big an NS data could I put in there? For example, could I put an NS data that is the real photo, the big, you know, maybe a megabyte size photo? And the answer is absolutely, you can put them in here. In fact, there's a little switch that you can turn on that says, I'm going to put something big here, store it in another file, okay? But even if you store it in the SQL file, it can usually manage it. It's probably not the best, most efficient way to do it. But yes, you can store big data blobs in core data as well. So there's some example attributes. Let's look at this a different way. If you see down at the bottom there where it says editor style, right? I clicked on that and it switched over to showing the same thing but in a graphical format. So see, here's my photo entity. I can see the attributes. See them there, listed there. And I can still create an entity in this view. So I'm going to create another entity, which is my photographer. I create that entity. I'm going to change the name to photographer. It changes it. Okay. I can also add attributes in this view. So I just go down to this button here, Add Attribute. I'm going to add an attribute here, and I'm going to call it Name. So that's the name of the photographer. You can also edit these attributes here in this view by clicking on them. all right, like clicking on the name, and then going up to this attributes inspector up here. Okay, so this is kind of like the attributes inspector in other environments inside of Xcode. So if I click on that, you can see I get a bunch of attributes of my attributes. So here's the name one, and you can see there's the name of it, and there's the attribute type, which you can see is undefined. That's why we have the error up there. See, attribute type undefined. So I'm going to click on that, pop up right there, and change that undefined to be string. The photographer's name is also a string. Okay, so we got that. I can also create relationships between these objects, photos and photographers. I mean, clearly a photo and a photographer have a relationship, right? A photographer takes photos. A photo is taken by a photographer. So I can create relationships between them by control dragging. That's how we like to do things in Xcode. We control drag. So I'm going to control drag between the photo and the photographer, and it's going to create this new relationship between them. Now, the relationship will have a different name on each side. On the photo side, we're going to call this relationship who took, because this relationship is for the photo, who took it. And on the photographer side, we're going to call it photos, because a photographer can take multiple photos, so we'll call it photos. Okay? So this is the same relationship, but it's going to have a property on each of these two objects, photos and photographers, that's a little different. Now, notice that from a photographer's standpoint, this relationship is not just a one-to-one, because a photographer can take multiple photos. And you can see that in the inspector for photos on photographer, there's a type that says to-one. Okay, that means it's a one-to-one relationship. I can actually change that to too many. And when I do that, you're going to see that I get a double arrowhead on that side of the pointer there that's saying a photographer can have multiple photos. Now, we talked about how title is a string and upload date is a date. What type is who took and photos? What type are those? Because they're just properties as well of these objects, but what's their type? And it turns out that something like photos, which is a too many, is an NS set. Okay? That's just going to be its type. Just like title is an NS string, photos is an NS set. What about who took? Who took turns out to be an NS managed object star. So it's a pointer to an NS managed object. NS managed object is the superclass for all objects in the database. Okay, so a photo is going to be an NS managed object, a photographer is going to be an NS managed object. In our Objective-C code, they're all going to be NS managed objects. So, of course, the who took pointer, which is a pointer to a photographer, is going to be an NS managed object star. And we're going to see how we can subclass NS managed object to add all these properties and all this stuff, and then it would be a photographer star, but that's what who took is. It's kind of exactly what you would expect. It's a pointer to an object, which is that other object. Okay? This little delete rule right there, I'm not going to go into detail about this, but the delete rule specifies what to do to who took. Okay, this is the delete rule for photos. You see I'm inspecting photos there. This is the delete rule that says, if I delete a photographer, what happens to who took? Okay? Because who took was pointing to this photographer, and if I delete that photographer from the database, and the answer here, this delete rule is nullify, which means who took would be set to nil. Okay? But there are other rules, for example, cascade, which means delete, when you delete the photographer, delete every single photo that it points to, right? Cascade the delete throughout the database. So you really want to know what you're doing here. The safest one is usually nullify, set things to nil. But if your database doesn't make sense, if a pointer points to nil, you might need more complicated delete rules there. But in your homework, you won't need anything more complicated than that. So that's basically how we build this map between objects and the database. Okay? So there's a lot of things you can do once you have this map. We're going to focus on the creating entities, attributes, and relationships, and then setting their attributes, and then querying for them and things like that. But there's a lot of other things you can do in core data. I'll mention some of them at the end, and you can go read up on it if you want to do more sophisticated database-y things. So how do we access all of this stuff?